Okay, so we'll kick it off. Thank you everyone for tuning in to our 5th session for our citizen science webinar series. So this is a partnership between the YESS community and the WMO WWRP High Weather project. And so we've come together to create this webinar series, and this is our 5th session. And tonight we have a really exciting topic on build, measure, understand citizen science for weather education. But before we head off there, we have a few things that we want to cover, just a few code of conduct and just a little bit of introduction about YESS and high weather. And then we'll go straight to introduce our speakers and go to the presentation. So as I said, this is a partnership between YESS and high weather. High Weather is a 10-year international research project with a WWRP, and it aims to advance how we look at high impact weather events to improve forecasting and warning. And follow us on Twitter. We also have our website too if you want to know more details. And Fatin will explain a little bit about the YESS community.
Yeah, thank you very much, Marion. Hello, everyone. It's really lovely to see you again for the first edition of WMO High Weather Impact webinars. Thank you, Marion, for introducing the awesome project. And we really enjoyed the previous session and the previous webinar that you can find them on our website. And before handing over to Dr. Henning from Freie Universität Berlin, I would like to give a brief presentation about YESS community, or the Young Earth System Scientist. YESS community is a network of early career scientists that unifies international and multidisciplinary early career research in a powerful network. So what we do is we try to provide a voice and promote the early career scientists for a better future and also to serve the society. YESS has been officially endorsed by WWRP and WCRP, the research arm of our meteorological organization, and YESS has close relationship with GAO. YESS also has representatives in international initiatives and organizations. We have, for example, representative at the research board of WMO. We have representative in Future Earth, and so. In YESS, we have every year elections. So for those elections, we have the executive committee and also the regional representative. And also, as you might see in the structure, we have 4 working groups. We have the science working group, the outreach working group, the membership working group, and also the online event working group, who is hosting this session with the High Weather Impact Working Group. So everyone can join YESS at any time and can be part of the working groups. And here we share with you all information about our social media, our contacts. So please do not hesitate to contact us at any time, and we'll be happy to interact with you and to answer all your questions. Now I move to the code of conduct. So please, Marion, if you give me the next slide. So before starting the webinar, we would like to kindly ask you to mute yourself. You are all muted, and all videos will be closed during the presentation, only the ones of the speakers. If you have questions, please type them on the chat box, and then we'll take them during the Q&A session. We also would like to inform you that we are recording all content of the presentation, the Q&A, and the message in the chat box. And after the webinar series, we will be sharing with you an outcome report that will be elaborated and will be published online. So thank you. And now I hand over to Marion to make the presentation of our speaker today. And thank you for joining us.
Thank you, Fatin. And I have the privilege of introducing our speaker tonight. And Henning, feel free to share your screen at any time. Okay. Henning is a physicist with expertise in statistics, working now as a professor for statistical meteorology at Freie Universität Berlin. He is a research area director for optimal use of information from weather forecasts for society at the Hans Ertel Center for Weather Research. a virtual research center funded by German Meteorological Service. Henning wants to involve citizens into atmospheric research to improve understanding and the use of weather forecasts and warnings, contributing to preparing society for more frequent and intense weather extremes. So we're very fortunate to have Henning with us tonight to share a bit about our citizen science initiative. Now, he's also joined by Thomas, his colleague. Thomas is a geographer from LMU Munich, Germany, and working on communication of risk and uncertainty in weather warnings. And he will help answer some of your questions later. So we're very happy to have both of them tonight. And when you're ready, please, you can start your presentation.
Yeah, thank you very much for the introduction. Thank you for giving me the opportunity to speak here. Although I don't have a very long track record on citizen science. In fact, 2 years ago, I was not involved in something like this. But by that time we had the idea, and it was something like a lucky accident, I would say, that I stumbled into this fascinating topic. And today I would like to report a little bit on this idea, and this idea is financed by 2 different projects, and both projects were supposed to take place this year, and if everything went well, we would have had a project with more than 200 participants by now and finishing right now. But most of the projects was moved to next year, but we could at least have a smaller test run. And so I introduced the concept and the first impressions we got from our first smaller test run, and we hope that next year we can redo this thing with a lot more participants. So Ops at School, that's what we titled it. The idea is to build, to measure, and to help understand people, the weather and the hazards. This is a project, it's actually an interdisciplinary project, and Thomas is here as well. There are other people involved. Thomas is from Munich now, he was in Berlin before, and Martin from the German Weather Service, and Nadine from the Max Planck Institute for Human Development. And besides these 4 more prominent placed here, there is those people who are doing the actual work, Christopher, Bianca, Jonas, Andreas, and François Audrey, and without them, it would be difficult to run such a project. So I structured the presentation into 4 parts. First, I introduced the core of our project, which we call the Messi. It's an instrument. Then I introduced some educational material, which we have at the site. Another part of the participation is also a reporting, which I introduce. And then there is a social science study, which is testing for weather and climate literacy. So what are our aims? We want to create awareness for extremes and their risks, also in a climate change setting. Yeah, extremes are going to be increasing, and it's even more important to be aware of them and to be able to understand whether there are warnings or not. We also develop some teaching material and also a concept for teaching. And we want to raise interest in weather and climate. And around all this, we also would like to investigate to what extent the participation stimulates the understanding of weather and climate risks, which we think is a way to prepare for climate change. Whether reported impacts can help to provide a databases for developing a new kind of forecast, impact-based forecasts or predictions, which translate what the weather will be into what the weather will do. And from a more natural scientist point of view, we would like to check whether the data we measure within this citizen science project can be used to augment a professional measurement network. So now I took up some slides and questions, definitions, which Lisa gave in the first talk in this series. She gave one of the many possible definitions for citizen science. These are projects in which volunteers partner with scientists to answer real-world questions. And I think this definition fits well to what we are doing. And later on in her talk, she also gave motivations for scientists, and I placed them here. And then we can check during the project, during my talk, whether these motivations are given also in our context, and I take them up later on. So data collection, education, and the development towards a change in behavior. That is the scientist's motivation. The participants' motivation is, first of all, fun. It could be an interesting hobby they have. They might learn something from this. That's also something we like them to do. And they are part of a community. And I bring up this slide at the end of the talk, and then we can see whether you think this happened here or not. So Messi. Messi is an acronym which comes from German. I say it once, so it might be fun. It's mein eigenes Subskaleninstrument. And it's can be translated, it's my own instrument for subscalar measurement. And it is due to a project which started the whole thing, which kicked it off. And it's a measurement campaign which is interested in the weather on the subscale, so like smaller than what the models can, or the general models can. So it's the scale of convective events. So what is the concept of this? It's supposed to be a relatively small and handy thing. It's about that big in size, a huge cup, so to say. It can measure temperature, relative humidity, pressure, and solar radiation. The participants, which we in our two projects decided to be pupils, grade 5 and upwards, they participate in assembling this thing. They don't build it from the scratch, but there are some parts I show it to you later, and then they can assemble it. And that is a way to bring this thing closer to them. Yeah. They have live data on the smartphone or on any device they have, a tablet or computer. It's basically a website. And we also wanted this to be independent from people's Wi-Fi. So they are relatively free in placing it in their garden, and it doesn't need to be close to a house, for example. Yeah, for obvious technologists, you don't want to be this affected by influences from the house, from walls. And it should be more or less self-sustaining. There is no power supply. There's a battery, but there's no cable. And as you can see here on the top, there are some small solar panels. They are about big. And they charge during the day. They charge the battery. Supposed to last a few months, and depending on where you place it, you need to recharge the battery with, every 2 months. So this is a printed circuit board, which is the core of the Messi. It has some sensors, which I explained here. I don't want. What I want to show you is that kind of rectangular is what people get, and they get external sensor, and they need to cut out the circuits. It's printed also, there are circuits also on the other side of the device, and it is basically the status from which they start to assemble. So then there's a rain gauge, which we added after being ready with the concept of the Messi. Another project which wanted to measure rain. So this rain gauge is something we did not develop ourselves. It's a standard replacement commercial weather station in cheap. As you can see, it's symmetric or circular symmetric. Nothing really meteorologists would like to use. Yeah, so it has some, and it could connect to our device. This is kind of an extension which we had for one. So the housing is partly 3D printed. Actually, we wanted to have it 3D printing, something which people of that age are very fascinated by. And we developed the housing. The prototypes were 3D printed in the beginning. At some point, we realized that for the about 200 devices we want to build, not meaningful things. So these 5 layers in the middle here, they are all the same, and we needed about 1,000. I just hear that my voice is not so good. Hello? It's better.
Hi, Henning. Can you hear us?
Yes.
Yeah, because the voice sometimes breaking sometimes.
Okay.
Oh, thank you.
I hope it's better now. So what we did in the end is we asked a company to produce the 5 middle layers, and the special ones at top and bottom we printed ourselves. And that can be also printed completely if the class wants to do so. That is what they look like. They come in our package, construct this thing, assemble this thing, and a step board already in there, and there's the end of the whole thing. So our plan was that we go into schools and we have like a full day of a workshop, 2 hours. We give some introduction and we help this thing. And then suddenly was the reality came, and no, not possible to have any workshops anymore. So, we need to develop a concept which is completely online. And that was something we had to do ad hoc. And there was then the task to come up with an assembly instruction, yeah, to make the, my microphone is supposed not to work. I have not, it's not easy to change. Okay. If it's okay now, then give me a sign. Otherwise, I need to rebuild things here. It's better now. Okay, then I try not to move. No, it's not better now. I'm not sure if it's the microphone or the internet connection, unfortunately. Oha. I can change the microphone if you think that's okay, if this is necessary. In the meantime, I give you a quick browse through this Aufbauanleitung, to this instruction. It's about 100 pages. And I have a video which gives you an impression, and it works. It runs 10 seconds. I show it to you quickly. And in the meantime, I change my microphone. So you got an impression. It's a step-by-step instruction, and the feedback from the pupils was that this was okay. They could. It was actually well taken. It was relatively easy to assemble this thing. Oops, sorry. Now I'm back. I said that there is no Wi-Fi connection. So there must be something else, and this else is LoRa, which is a long-range radio connection designed for Internet of Things. And here, this is the gateway. That's basically the receiver. There is a cable coming from the antenna. Then there's a small thing. I put a bottle here to see how big it is. And it's connected to the internet, and it receives the messages from the Messi and sends them to a server in our institute. So we placed, this is our test area. We placed a few of these gateways, yeah, here, there, there's a gateway, and there's one over here of our gateways. And these kind of LoRa gateways, they are public, so other people can place them as well. And that's what some people did here also in the surrounding. And they have a reach of a few kilometers. So it should work actually quite well, but this is a relative mountainous region, and we had some problems, which I can show you also later. So we needed a little bit, for next year, we need more gateways here. So this is then what the pupils have on their smartphones or their computer. It's an app which gives them the live data of their instrument. So this is the temperature, and the red line is the temperature of their instrument. And the gray lines here, that is neighboring instruments. They don't know exactly who it is. That's like data, personal data protection. But they can see that the temperature varies in a relatively small range, yeah, which is a few kilometers. So they see other instruments, and they see that there is a variation in space. And they can see this also for precipitation, for example, or the other variables they measure. So it's actually, I was really surprised. That is very nice work from Bianca. She programmed this from the scratch, more or less. And it adapts to your screen. So if you have it on the computer or on the smartphone, it looks nice. So educational material. We wanted to have these workshops, which you could not have. So we needed to develop a concept which relies only on digital material. So that's what I just said, some digital material. We prepared some talks which we would have given during the workshops, which are recorded as videos now, like this one. But also some colleagues of mine, they came up with explanatory videos in form of cartoons, for example, or there's a song. And also we want to have, which is not yet finished, experiments which they can do at home in this context. All this was taking place in Germany, so this material is in German, as we were addressing grade 5 and 6, and they are not fluent in English. If you're interested to look, there's this link, and you can have a look at the material in German. And I give you a small impression. There is a cartoon a colleague of mine, Nico, made. It's about 4 minutes, but I give you only an impression, and I play the first 10 or 20 minutes. I was just told that when I click this now, it might become very loud, but I don't have any means to control this, so be prepared.
Woher kommen eigentlich Unsicherheiten in Wettervorhersagen? Stell dir vor, morgen ist Wochenende und es werden ein paar Wolken und Sonnenschein vorhergesagt. Du verabredest dich draußen mit deinen Freunden und es regnet in Strömen. Woran liegt das? Warum liegen Wettervorhersagen manchmal so daneben? Woher stammen diese Unsicherheiten in Wettervorhersagen? Um diese Frage zu beantworten, schauen wir uns als erstes 2 einfache Experimente an. Stell dir eine schiefe Ebene vor. Auf diese schiefe Ebene legst du eine Kugel. Du möchtest vorhersagen, wo die Kugel am...
Okay, if you want to see how it turns out, this experiment, you have to go on the web page and see how it works. Yeah, this type of cartoons, we have 2 or 3 and another talk recorded. And this is something we want to extend also for the next year. So then at the beginning, I mentioned that there is another component to it besides this automatic measurements. The pupils can report weather and their impact. They go on a web page and then they can report what they see, what is happening. So the first part is reporting the weather, and this is how the web page looks like. It is in German. So the first question is, how strong would you say the wind is? And then you have this slider. Yeah, so it's not like it's translated into numbers in the end, but for the pupils, it's a slider here. Next one is how strong would you think the rain is, yeah, and then you have hail and thunderstorm. And additionally to the weather itself, there's also the possibility to report impacts with these clicks here. Yeah, you can then say whether well, it's raining, but the water goes into the ground, yeah, or it sits on the street, or it's blocking an undercrossing or something, or there are branches falling off trees. These things can be reported. And this is an example of things which have been reported during the period in summer in one of our test areas. So the orange circles is where rain was reported, and the blue triangles is then an impact. So the blue triangle is where water is on the road. And if we want to have it a little bit more, a little bit stronger, the impact, the green squares say that water accumulates on the road. And the red square, the squares are where water, for example, stands into undercrossing or into parts of the road which are a little bit deeper. So with these reports, you can also do another experiment. You can confront the pupils with their reports and their measurements. So here the blue bars is precipitation and the red dots are reports. And then they can see like whether when they report or when they think the rain is strong, they can now also go to their measurements and see how strong it actually was in numbers. And don't be confused, here was no measurement reported. It was raining actually, but the device did not work. So the reports say some rain, but the device did not give any rain. So that was these technical issues we had with our gateways. Sorry. So after the period of measurement, which was during the summer, we went back to the schools, at least digitally online, to have a workshop on the data and on their questions and how it was, how they liked it. So first question we posed is, where did you put your device? Yeah, and here's a collection of pictures where people put the device on the roof, or here, for example, very close in a niche, yeah. And we asked them to draw a little sketch where the device is and to orient this map in the space, so we know where south and north is, whether there's direct sunlight or not, whether there's shadow from these bushes here, what is the ground, yeah. And then we discussed what would be a good place to put it, or why you should not put it on top of this road, yeah, which is a dark grounded road, why grass would be good, or shadow or not shadow. We discussed that with them. And as a second part in this workshop, we discussed the measurements from them. So they all got some kind of analysis, basically pictures, these analyses we made for them, but the data is from their device, yeah, and then they can look at some simple statistics. But what was actually more interesting was we provided them the data in form of numbers. That is their data, which they can look back at, like it's the data from one summer, and we helped them to analyze this data in a spreadsheet. That was very painful for me, because you very quickly feel the boundaries of spreadsheets once you have 10-second data for a few months. Then that's more than a spreadsheet can handle. But we somehow meaningfully aggregated this data to make it possible to work with this. So we also helped them to transform the data. Yeah, the precipitation was transformed from the tips this tipping bucket had. And we showed them how to make a plot. And this is an interesting day where suddenly, this is temperature, the red line, and it suddenly dropped. Unfortunately, here was a cutout from the gateway. And then it started raining. So this was the arrival of a front with rain, which we can which pupils could derive from their own measurements, and we discussed that with them. So, and surrounding all this was a social science study on testing weather and climate literacy. So the idea was that at the beginning of the whole project, we had a pretest with a group which will be participating actively, receiving and assembling a Messi and discussing things with us during a workshop, and there's a post-test. And then there's a control group which did not participate. And the idea was to see how strong the effect of participating is here. So questions cover knowledge, perception, behavior questions, and attitude. I'll show you a few examples soon about climate change, extreme weather events, and risks. And they were also covering interest in science, technology, engineering, and mathematics. And these questions are taken from Nadine's paper on weather literacy in times of climate change. And this is an example of a few questions about knowledge. Yeah, how has the climate changed in Germany since 1880 in terms of hot days above 30 degrees, cold days below 0 degrees, the number of days per year with at least 10 liters of precipitation per square meter, and so on. These are only a few examples. And on the attitude, how much do you agree or disagree? I'm not sure that climate change exists, for example. How worried are you about climate change? I think my area will be strongly affected by climate change. I think I can have a positive impact on climate change. These things were also asked. So now coming back to the slides I brought up in the beginning, which I took from Lisa McLaren's talk, the first talk in this series. The motivation for scientists, data collection, education, and working towards a change in behavior. And from the scientist perspective, I would tick off all those three. I would say that, yes, that worked for us. For the participants, that's something we are currently evaluating, but the first feedback from our workshop was that they all had fun. They all find it interesting, and having one of these devices at home was something like a hobby for them. Whether they learned something or not, that's something which we are currently evaluating. We are evaluating these tests. And to what extent they liked it to be part of it is also something which we asked, but we haven't evaluated now. Like we had these workshops and tests last week, so it's relatively fresh, everything. So citizen science and weather and climate research. I took up 3 points, which Lisa raised in the first talk. Encourage community participation in hazard research. Did we contribute to this? And I would say yes, we enabled precipitation measurements with a high spatial resolution. So if you have, as we planned, 100 instruments for 2 or 3 schools, then we have a very high coverage of precipitation measurements that is a lot higher than professional instruments are placed. What we were thinking to do, if we realize this project within the frame of an urban context, we can have a local heat mapping from the temperature sensors. And we want to use the reported impact observations for impact modeling. So increased understanding of hazards. Our approach was that we confront the pupils with the numbers, the measurements, and we ask them to confront this with their perception of weather, basically through the instant visualization of measurements. And so they get a better feeling for the numbers. Yeah, what do those numbers mean to me and to my environment? And that is basically the fundamentals to understand a weather prediction or a hazard warning, which is then given in numbers. Yeah. And we did this in an educational way during our workshops, but also in practice. And I think that's something which is really important, that they do this on more or less daily basis, yeah, and actually look at numbers and see what those numbers mean. And this helps also for the forecast, yeah, for the warnings. So they document the hazard impact by reporting these observations. And that is basically a basis that we can show like these impacts have been here, and that can be arguments to convince people to do something against these impacts on a local basis. So what participation type are we? There's this topology of citizen science project, which Lisa also presented. And there's like the very low level citizen science where citizens only contribute. Yeah, and we designed the experiment, and that's, I would say, that's what we did. The next level would be collaboration. So there's additional help in project design, analysis, and dissemination. Well, I would say in the project design partially, but there is help in the analysis and dissemination by the participants. And the highest, like the extreme citizen science level, would be the co-create level, where citizens and scientists work together and citizens are actively involved throughout the process. And that's something I would say we don't have. I wouldn't claim that we have this. Okay, so finally, to sum up, I presented you a citizen science project which is targeted to pupils. It is centered around an instrument which is relatively cheap and easy to assemble for pupils. They can deploy this instrument in their garden or on their balcony. There is educational material which can be used in a workshop or also online. And another part of this is the reporting of observations of weather and impact, yeah, which helps to tie this connection between numbers and feelings. And all this is framed by social science study on testing weather and climate literacy. So that is the end of my talk. I hope you could enjoy this and take something from it. And I'm now looking forward to your questions.
Thank you, Henning. That was a really interesting presentation. And I really liked it how you connected it with Lisa's first talk, and tried to answer some of the topics that she raised. So thank you for that. Yeah, we have a few questions from the chat box, and I think Faten will try to read some of those. And for our participants, feel free to put in more questions in the chat box, and just pop in those questions, and we'll try to go through the questions that you put in. So I'll hand it over to Faten to ask some of the questions that the participants have asked.
Thank you very much, Marion. Thank you very much, Dr. Roos, for the impressive talk. It was a very informative session. I really liked this. And also, it was really very great to me to see the education material and the instrument used for the weather education. So really congratulations for this awesome project. I can take the few questions I have here in the chat box. The first one is coming from Marion, and she's asking, what are some of the challenges you faced in engaging with students? Dr. Roos, you are unmuted.
Yeah, sorry. Okay. Yeah, I would say the biggest obstacle to overcome was to reach the students. We were asking first at the schools, at the official secretary, and it was difficult to reach actually a teacher who says, I'm interested. That was in our first project area very difficult. In the second project area, we had already contacts. We were working together with a kind of foundation which works there on this topic already, and they had contacts to some teachers, and then it was a lot easier for us. And there were a few teachers who were really motivated, and there was an obstacle to get in contact with the students themselves. That was relatively easy then, besides the fact that everything was online. Yeah, the contact was kind of hampered by not being there physically. There was one exception. I went there for a few days to help with problems, and there my impression was that they liked the project and they were happy to be in contact with us. Yeah, but the biggest obstacle was actually to get into the school and present something which they might find interesting or not. Especially it was the first attempt for this project. So we could not say that, see, we did this with this school and it worked well. So it was like the first go, and that was problematic.
Yeah, thank you very much, Dr. We have another question from Marta. She said, very interesting how people were engaged in this initiative. How did you choose who will be participating and how many participants there?
Mm-hmm.
The first question. Can I ask the second one from the person, or you prefer to answer this question and we can go to the second one?
Okay. How did we choose? So on our first project area, we selected the schools which we will ask by their location. The first project area was relatively bounded. Yeah, that was the experiment we wanted to have. It's a bounded area at a certain place, and there are not so many schools. So we asked about 10 schools and 4 replied. Yeah, and these were the 4 schools we worked with them. And then came Corona and we didn't work with them in the end, but that was the idea. And in this project area, we planned for about 150 participants. And the second project area, our partners had already contacts to 2 schools, which we then just used. And for our smaller campaign this year, we had 25 participants, but this project was designed for 70. Plus control group.
Thank you very much. There is another question from the same person, Marta, and she's asking, we are there. There were any instances where participants were not able to install the instrument properly, and how were you be able to assess such scenarios? You are muted, Dr. West.
Oh, sorry, seems to be automatically. There were not many cases where this happened. It seems to work quite well with these instructions. But there were cases, and sometimes it was due to a broken part they had, or they broke it through by assembling. And as we couldn't go there in the first place, there was like a kind of a reservoir of parts, yeah, which could be distributed. We had kind of a question-answer session online. So after they had the chance to assemble their device, and they could meet us in a video conference and show problems, which we then tried to assist. And there were still some cases, and during the summer here, I was able to go there, and then I had like 2 days where I offered that the pupils come see me and repair this instrument. Yeah, and so I had like 5 or 6 pupils who came to this kind of helping workshop, or would you say this? Okay, but in a larger scenario with many pupils, and we cannot go there if there would be still this pandemic scenario next year, then we need somehow train the teachers or something. That is actually, that would be a problem. If this happens and we have more than 25 participants, it could be problematic. But I think we can benefit from this year's experience to overcome these difficulties which we experienced this year, and hope that they at least won't occur next year.
Thank you very much, Dr. Rust. I take the third question is coming from Dr. Muhammad, and he said, nice talk. Science and social application outreach are very important. Is the education material freely available in English language?
Freely available, yes. In English, no. But yeah, I really hope that this type of projects can be exported also to other countries. But for now, the material is in German, as I said. And I don't think there's any material which works without voice and words. No. So no, not in English.
Yeah, thank you for that. And I actually have a follow-up question in the video because I think it's really cute and really good kind of graphic. Quite simple, but I think quite interactive. And what was the idea behind that? And kind of what was the thought process behind the design of the video? And how was it perceived by the students? Did they enjoy it? What was the reaction? Did they get to do the experiment? And how did you get kind of feedback from that video that you made?
First, the last question, we did not get so much feedback. We got feedback to the bundle of materials saying the bundle is nice. And the story how this video, which I showed you the first 20 seconds, was that we actually had this experiment live. Yeah, we wanted to show it live in a workshop. We had this kind of ball which rolls down a slide and so on. Yeah, you need to watch it to see the rest. And then we suddenly realized that we cannot do it because there's this pandemic situation. And then I asked a colleague if he can make a movie and film this experiment. Yeah, and it's difficult to make a movie of this ball which rolls down because it's so quick. And he said, yeah, he couldn't find the switch for a slow motion video. So he just sat down and drew everything. And I was really overwhelmed by this. I could not do this. And I didn't know that he has this capabilities to draw things. And it was like, yeah, I couldn't find the right button. So I just did it completely differently. See if you like it. And I think it was great. And that triggered another colleague to make another cartoon. And also I prepared some experiments and I spent some weeks of thinking, how could I do this as a video? And it didn't work. And during my summer vacation, then I came up with a song. And I made this song. I wrote it, but I cannot really sing. So I gave it to a colleague and she made a cartoon and sang this song. And that is basically what you see in the upper right as the title picture for the educational material. There's a song behind, which you can also see on the web page. And yeah, it's catchy, I would say. My kids sing it now all the time. And it's about probabilistic weather forecasts.
Yeah, thanks. That's really quite impressive to get different skills from the different members of the team. That's pretty fun. And I think it's probably we try to adapt based on the pandemic situation. And I follow up with the question from Dr. Mohan. He said, how does the pandemic situation affect this citizen science involvement activities? And maybe just reflect on how your project has changed because of COVID, and then and how you've adapted. And we can see that you've brought out your creative juices to create new materials, but maybe a bit more reflection on that and answer Dr. Mohan.
Yeah. The beginning of this year in January, we had a meeting on this project, on this a measurement campaign where this project was embedded to see how this could start. And there was the virus in China, but it was not in Europe. And we needed some parts for our instrument from China, and they were delayed. And that was kind of the thing. Now the pandemic affected, the pandemic affects our project, but we found another supplier and we thought that's it. Yeah. But then suddenly the real effect came, so we could not go to the schools. And I would say that this was, in the end, it's probably good. We planned on having digital material anyway, but not so quickly. And we did not have an idea how that should look like. Yeah, and due to this situation, people were also sitting at home. And what we did, we ordered graphic tablets, for example, yeah, to enable them to draw things on the computer. And they were probably sitting at home with their kids and coming up with videos and songs and so on. So somewhat the situation actually shaped the project, but in particular, whenever we have contact or we're supposed to have contact with the participants.
Thank you for that, and really interesting initiatives, and just want to reflect back on some of the comments that we've received from our viewers, and they really thank you for your presentation and thank you for answering the questions, and it has been a really insightful talk. But I want to take this opportunity to maybe ask Thomas to maybe share a bit of reflection and share a little bit on his role in this project, and just share a bit to our audience and say hi. And yeah, thanks.
Yeah, thanks, Marion. Yeah, I totally agree with what Henning said. It was a challenge, but I think we made the best out of it. So I was mainly involved in the reporting of the impacts and observations of weather. This was a particular challenge because we had such a smaller group than we first thought at the beginning of the project. And as we were really involved in building the devices and setting up all this, the technical infrastructures, doing a lot of things from remote due to the COVID pandemic, that was of our took most of our time, so to say. So it was quite difficult to address the topic of the impacts within the engagement with the pupils. But at the end, I thought it was quite interesting, as Henning showed us, to compare the impact reports with the actual measurements of the weather. And I think that triggered some thoughts within the students and for us as well. And now we have like a lot of data, and then we have to look into it. And we try to repeat this measurement campaign next year again, and then we have more data. We have learned a lot of things from the students, from their feedback, what worked well, what didn't work well, how we designed the app, how we designed the questions. So that's now revisited, and I think as Henning said at the end, I think we can tick a lot of the boxes of the goals we aim for, but there are still open questions, which is nice for research. And there's
Thank you.
Sorry.
No, sorry, please continue.
I just wanted to add that there's a lot of questions which pop up, which you have not thought about in the beginning, which come to things which maybe you're not that close to, how obviously everything related to the pandemic. So you have to think out of the box and be creative, which is nice, to be honest. Sometimes that's something you're not used to. And then it's really nice if it worked out. And so all the teachers and the students were really helpful, and they will quite keen on working with us, and they have really showed interest. And so this was, at the end, it was actually quite an easy task to do, I would say, more or less. So it's a challenge, but it was a fun challenge.
Yeah, I can see that, and yeah, it's really great initiative and great work with you and the team and getting this done, even in a pandemic situation. And I guess it does push us to think out of the box, and great to see that the project is ongoing and looking at trying to adapt to our situation. I guess it gives a bit more inspiration for people in this situation in the pandemic as well. Thank you for your presentation. It was really great. And for me, it's really interesting, and I kind of want to reflect back on what Henning said, that it's really some of the engagement, starting with school teachers, might be a good way to start to get to the pupils getting involved. Myself, I'm doing a project with schools as well. So I really appreciate that kind of suggestion, and kind of really appreciate the sharing of your experiences and what you've done in this project. So thank you for your work, and thank you for sharing your expertise. And I'll just hand it over to Fatin to say a few words of thanks and close this session.
Yeah, thank you very much, Marion. Thank you very much, Dr. Roost, for the impressive talk, and also for the attendee for the fruitful discussion and for the great interaction. Mr. Cox, for sharing your experience. And for me, it was really great to see how young people were engaged with such projects. And I really believe that more initiative in this way should be there, because we need education on weather, we need education on extremes, and we need education on climate and all related issues. I posted in the chat box the link of YESS community webinars and also the concept note of this webinar series. So feel free to check the content of the concept note and also the website. You will find there all previous recording of the webinars and also all information related to this event. And we'll be glad to interact with you. So if you have any question, if you want to share with us any of your comments, we will be very glad to hear from you. So thank you very much. Thank you for the great session today, and goodbye from my side.
Thank you, everyone. Thank you, speakers. Thank you, participants, and really enjoyed running this webinar series. See you all.
Yeah, thank you also from my side. It's a good thing which you are running there. I like the other talks as well very much. Thank you.
Thank you.
Bye. Bye.
Bye-bye.
Bye.